with the biosphere, it's primarily sea whiffs, veers, is it aqua modus?
Yeah. And it's you look at this image, and there's so much here that we still don't understand.
I agree with Gene. We're looking at the consequence of instruments on satellites, not looking away from Earth, but looking at Earth through time, how things change, how things vary or don't. It's just fascinating to look at, and it's so dynamic. And this is what's great about time series.
Well, that's one of the thoughts I had, was that the people in this room right now, if you ask yourself the question, what have I done to make sure that the Earth is a healthier and safer place, I think the people in this room can fairly say that they've done quite a lot in collecting the data and then creating the data in a way people can understand it.
What I love about this is there are no country boundaries. There's no distinction between land science and ocean science, or it's one world, one planet, one home.
Yeah, this is our living planet.
Exactly, and the more we, as humans on this planet, inhabitants of the planet, look at this as one entity that we are all responsible for, I think the sooner we will be able to come up with solutions to a lot of the problems that we're facing right now. We have to look at this as one planet, where what happens in one place affects what happens in another place.
One planet, one climate, one people. We're all in this together.
This is Hubble Telescope's famous photograph, Hubble Ultra Deep Field. There are nearly 10,000 galaxies, each containing as many as 100 billion planets in this image alone. But the question has always been, out of those billions of planets, how many could have life? Observing Earth's global biology on a massive planetary scale has given scientists the tools to answer always been, out of those billions of planets, how many could have life? Observing Earth's global biology on a massive planetary scale
When I talk to people about this, about the search for life on all these planets we found around all these other stars, a very common response I get is this line from Contact. Well, if there isn't anything out there, it would be a horrible waste of space, which is a wonderful line. And especially was a wonderful line 20 years ago. But now we're beyond that.
That's Dr. Sean Domingal-Goldman. He's one of NASA's many scientists heading up the search for life.
I'm a research space scientist and astrobiologist at NASA Goddard Space Flight Center. What I do at NASA is I look for ways to look for life on other planets.
10 years ago, conversations about life in the universe were mainly limited to bar talk and philosophical conversations. But that's all changed.
We can now apply the scientific method to the question of, are we alone? We, based on our understanding of how life operates on Earth, are starting to derive principles of the signals that life creates that we could then look for on these planets around other stars.
But with a universe as vast as ours, where do you even begin looking for these Earth-like planets? NASA scientists must take an extremely calculated approach when it comes to combing the universe for signs of life. By studying Earth's climate over its long history, we have a pretty good understanding of how climate operates on other rocky planets. And that gives us some helpful clues on the distance from a star and the size of a planet that could harbor a global biosphere like the one we have here on Earth. It all comes down to knowing where to look.
We have a concept for this. It's called the habitable zone or the Goldilocks zone. And the basic idea is you can't be too hot because otherwise you'll lose your oceans. They'll basically boil and steam away. You can't be too cold because then your oceans will freeze over. You want that big sort of global ocean reservoir at the surface, which happens when you're kind of in the middle and just right.
In our solar system, the Goldilocks zone is bound by Venus, which is too hot and steamy with no oceans at the surface, and Mars, which is too cold and too small. And size matters too. To give an example, the moon is technically in just the right place. It's in the middle of the Goldilocks zone, just like Earth is, and it gets the right amount of energy from the sun. But it's too small to hold on to an atmosphere. And the same thing goes for planets that are too big, like gas giants, where there's too much pressure bearing down on liquid water.
We're on the Goldilocks planet. And what's really neat is we found a lot of other so-called Goldilocks planets in the last few years that we could then think about looking for signs of life on in the future.
The studies Sean is talking about have been coming out pretty consistently since the early 2000s.
The recent uptick in exoplanet discoveries over the past 7 years or so is due in large part to the Kepler Space Telescope, which found over thousands of exoplanets orbiting other stars.
One cluster of planets after another, astrophysicists have discovered a mind-blowing number of worlds that are the right size and distance from their star to potentially have conditions for life similar to Earth.
The most amazing thing that Earth has taught us is that life can really exist in very dramatic environments, from really hot environments in the middle of a desert to really cold environments with little light at the very bottom of our ocean.
Based on what we know about Earth, the fundamental cocktail looks like this. You need liquid water, the right atmospheric gases, and, if you're lucky, specific global signs of life. Everywhere we look, whether it's a desert or Antarctica or the deepest parts of the ocean or the deepest parts of Earth's crust that we've explored, as long as there's a tiny speck of liquid water, there's life. And because of that, it's been central to NASA's search for habitable environments elsewhere. It's why scientists get excited about water spewing up from the icy moons of Europa and Enceladus in our outer solar system. Not only could they have water, but they could have global oceans like the ones we have here on Earth. After liquid water, we'd look for atmospheric gases. Actually, the gas we're breathing now, oxygen. Find oxygen and methane together in the same atmosphere, and you've got something special.
There are ways to build up oxygen or methane in the planetary atmosphere, but the only way you get them both in the same atmosphere at the same time is if you produce them both super rapidly. And the only way we know how to do that is through life.
The next thing scientists could look for is pigment, the colors of life, like the chlorophyll found in plants on land and algae and phytoplankton in the ocean. Although there aren't currently any outer space missions in progress to retrieve this data, we could, in theory, be able to detect similar colors on a planet around another star in the future. But maybe one of the coolest things about this whole enterprise is how quickly we're learning.
I firmly believe that one of two things is going to happen in the course of my scientific career. Either we're going to find evidence that we're not alone in the universe, or we'll have so exhaustively searched for it and not found anything that we'll know that the universe is a lonely place and that our place in it is more special because of that. Either way, I can't wait to find out what we uncover in the next 20 years.
Honoring our fallen heroes, working on a nuclear option for space travel, and the next crewed mission to the space station. A few of the stories to tell you about this week at NASA. Our annual Day of Remembrance observance at Arlington National Cemetery took place on January 26th. The event honors the astronauts of Apollo 1, Space Shuttles Challenger and Columbia, and others who lost their lives in support of NASA's mission of exploration and discovery. The observance also preceded the 20th anniversary of the Columbia accident on February 1st. On January 24th, we announced a collaboration with the Defense Advanced Research Projects Agency, or DARPA, to demonstrate a nuclear thermal rocket engine in space that could help enable crewed NASA missions to Mars. Learn more at nasa.gov/spacetech. The members of our SpaceX Crew 6 mission, including NASA astronauts Stephen Bowen and Warren Hoburg, previewed the mission during a January 25th Crew News Conference at our Johnson Space Center. Crew 6 is scheduled to launch to the International Space Station no earlier than February 26th. Our Webb Space Telescope team has been selected to receive the Space Foundation's 2023 John L. Jack Swigert Jr. Award for Space Exploration. This annual award honors a space agency or other entity in space exploration and discovery. That's what's up this week at NASA. For more on these and other stories, follow us on the web at nasa.gov/twan.
I watched our astronauts up in the space station on YouTube, how they function in zero-G to try to mirror some of that. The Peter Pan production, where you're hanging from wires. So basically what they did with me was just strap me up to the ceiling and then have me spin until I got nauseous to find out where that threshold was, so we wouldn't be doing that on set in a giant spacesuit. Well, it's hard to beat Armstrong's message, so good luck.
Third Rock Radio, America's space station. Its ongoing mission: explore new worlds of music. Tell the
you